Okay, we're in the fourth video in Chapter 6. We're going to move past ionic compounds now. We're going to move into binary molecular compounds. So remember that we've got elements, and elements can form ions. We also have compounds. There are two types of compounds. There are ionic compounds, which we just looked at, and there are molecular compounds. Remember that molecules, if you look at a molecular formula, do not contain metals. They only contain either nonmetals or nonmetals and a metalloid. So a binary molecular compound only contains two different atom types, so either two nonmetals or a nonmetal and a metalloid. So notice there's no metals in the formula. It must be molecular. How are we going to name molecular compounds? Well, we have to have a different naming system. For ionic compounds, we had ions, and we named them the cation and the anion ending in "ide." And then if the cation had more than one charge, we indicated that either with Roman numerals or through the classic naming system with the us and ik from the Latin or Greek names, whatever the element used. For molecules, we do not have ions at all, so there's no balancing of charges for the compound. Remember, the compounds are formed by the sharing of electrons, so there's no charges inside of the compound either. When we go to name the compound, instead of doing cation and anion, we're going to name the elements, and we're going to use prefixes in front of the element names to communicate how many of each element there are. So let's look at the actual naming rules. If you have a binary molecular compound with two nonmetals, the first thing you're going to do is you're going to look at the first nonmetal. You're going to write the name of that nonmetal first, and you're going to use a prefix in front of the name if there's more than one atom of that element. What are the prefixes? The prefixes are shown here on the side. You're going to need to know these. If you have one atom, you're going to use the prefix mono. Now, I'm going to put parentheses around this, because for the first element, it says when you write the name, you're going to use a prefix only if there's more than one of that element. So you'll not use the prefix mono for a first element name. If you only have one of that element, you're just going to name the element. And this will make more sense when we show some examples. If you have two of an element, you're going to have a di. So let's say you have two carbons. You would say dicarbon. If you had three, you would say tri. So maybe triphosphorus. If you have four, you're going to say tetra. Like tetraoxygen. I don't know. If you have five, you're going to say penta, like pentoxide. If you have six, it's hexa. Be very careful with this. A lot of people for six will say sexa or septa or something like that. It's hexa. So we're going to use that prefix system. For seven, it's not septa, it's hepta. So we go from hexa to hepta. 8 is octa, like octopus. 9 is nona. And 10 is deca. So we're only going to know the first 10 prefixes, but trust me, there are many more in the naming system by IUPAC. So I want you to learn these, and we're going to apply them to these rules here. Alright, so for the first element, if you have more than one of that atom, you're going to use the prefix di all the way to deca. Then you're going to write the name of the second element, but you're not going to use the entire name. You're going to use the stem of the second element name, and then you're going to finish the word off with the suffix "ide." Sounds very familiar, like chloride, iodide, and the ionic compounds. The second element here will also end in "ide" from the stem name. For the second element, though, you will always use a prefix to indicate the number of atoms. So even if you have 1 of the second atom, you're going to use the prefix for 1. So let's look at an example. The first example we have here is the compound CO. You're not going to call it CO though, because you're going to know the name of the compound when you read it. But notice we have a carbon and we have an oxygen. If you look on the periodic table, those are both right of that staircase, so they're both nonmetals. This is a binary molecular compound. So we're going to name it using prefixes. So we're going to name the first element first. The first element is carbon. And notice there's only 1 carbon there. There's not a subscript below it. So we're not going to say monocarbon. For the first element, you only use a prefix if there's more than 1 of the elements. So we're just going to say carbon. The second element here is oxygen. For the second element, we're going to use the stem of the second name. The stem of oxygen is ox. And now we're going to add "ide." But I'm missing something here. We're missing a prefix to the name. Because there's only 1 oxygen, we're going to use the prefix mono. However, if we write monoxide, that looks very funny, doesn't it? It looks like monoxide. Whenever you have an O, you're just going to get rid of the O on the mono. So it's just going to be literally monoxide. So the name of the compound, when we combine the first and second name of the elements with the prefixes, will be carbon monoxide. I'm sure you've heard of that one before. We've got those detectors in our house. If you have a fireplace, you most likely do. Alright, so that's carbon monoxide. Let's look at the second example here. The second example is N2O4. So we've got nitrogen and we've got oxygen. We notice once again they're both nonmetals. We have a binary molecular compound. So if you only have nonmetals, you're going to name using prefixes. So notice the first element contains 2 nitrogens. So we would say di. And then you write out the whole name for the first element. So this would be dinitrogen. And notice now that we have 4 oxygens. 4 is tetra. So we're going to write tetra. And then we finish up with ox and endenide. So it's dinitrogen tetraoxide. Dinitrogen tetraoxide. I think these are pretty easy. Once you just, the hardest part of nomenclature, really, the chapter, is just learning the rules and applying them. So see if you can do some more examples, work as many of the problems in the book, and we're going to move on. So can we go in reverse now? If we're given the name, can we give the formula? Not so hard, right? Alright, here's the first one. It's arsenic pentachloride. Now, here's the common mistake people make. They read left to right, and they're like, oh, I know these, they're really easy, and they start writing quickly, and they make a mistake. Notice here that it says we have arsenic. Do you see a prefix before arsenic? No. So for that, we assume we only have 1 atom. So we have arsenic, and it says pentachloride. Penta is 5, so we have 5 chlorines. Why did I tell you to be careful with this one? The number 1 mistake I see on this problem is that people will read left to right, and they will write left to right. They will see arsenic pentachloride, and they'll go arsenic pentachloride. But are these the same formula? No. The correct answer is that there's 5 chlorines. The way that they've written it quickly left to right, by the way it sounded, arsenic pentachloride, is they've written 5 arsenics. This is not correct, so just be careful when you're writing them quickly. Alright, silicon dioxide. So silicon is Si. We only have 1 because there's no prefix there. And then it says dioxide. So we've got oxygen, and we've got 2 of them. Nitrogen trichloride. Nitrogen. No prefix, so just 1 nitrogen. Trichloride. 3 chlorines. Let's come up here and look at these two and name them real quick. What is NO2? NO2 is nitrogen dioxide. What is N2O? It's dinitrogen monoxide. Remember that for the second element we do use the mono prefix. Notice that the 2 is just in a different spot. These are 2 different compounds. So you have to be very careful when naming the compounds and when writing them down, or you can come up with different compounds on accident. Alright, now we're going to look at acids. So right now, if we looked at compounds, we've looked at ionic compounds, binary ionic compounds, binary molecular compounds, non-metal, non-metal, no metals there. And the third class of binary compounds that we're going to look at are acids. Acids from binary compounds. Now, how do you know you have an acid? Remember, if you have an ionic compound, you have a metal, non-metal. If you have a binary molecular compound, you have a non-metal, non-metal, or a metalloid, non-metal. If you have an acid from a binary compound, then your compound will begin with the element hydrogen. Typically, the formula here is hydrogen and then some other non-metal. You'll have so many hydrogens and so many of the non-metal. So if you ever see a formula start in hydrogen, and that formula has an aqueous symbol behind it, which means dissolved in water, AQ means aqueous, dissolved in water, then you have an acid. How are we going to name acids? We're going to use the system of using the word hydro as a prefix to indicate the hydrogen bound to our non-metal. So we're going to say hydro, and then we're going to put the stem of the non-metal name followed by the suffix ic acid. Alright? So literally, if you have an acid, H, X, H something else, whatever the non-metal is, that will be in the middle of the word, of the name. The binary acid name is always hydroblankic acid. For example, we have HCl down here, aqueous. When we look at this, we see, oh, we've got 2 different types of elements. We have a binary compound. Well, what type of compound do we have? It's not ionic. We don't have a metal, non-metal. It's not molecular, because even though we do have a non-metal, non-metal, this compound's dissolved in water. It's aqueous, which tells us that the compound's going to actually react with the water. It's going to ionize in solution is what's going to happen. So it's a molecular compound that ionizes. This is a special type of compound called an acid. So we're going to name it as an acid. It starts with H, and it has a non-metal attached. So we're going to use the word hydro. Our non-metal is chlorine, so we're going to use the stem chlor, and then we're going to end in ic acid. Now you've probably heard of this acid before, hydrochloric acid. Hydrochloric, by the way, is one word. The hydro is the prefix to the non-metal name. Alright, so hydrochloric acid, that's HCl dissolved in water. How would we name this compound if it were not aqueous? What if it was the normal gaseous state? We would just name it hydrogen chloride. We would actually name it as the salt. It's very interesting. Alright, so let's name some other binary acids. Here we have aqueous HBr. We see we have hydrogen at the beginning again, and we're aqueous dissolved in water with a non-metal attached. So we're going to name this hydroblankic acid. It's a binary acid. This will be hydrobromic acid. The brome is the stem for bromine that's going to go into the naming system. So it's hydroblankic acid. The blank will be whatever the nonmetal is. In this case, it's bromine, hydrobromic acid. What happens if we're not in an aqueous solution? Well, the compound won't completely ionize or react in the solution. So instead of naming it as an acid, we would just name it as the ionic compound. We would call it hydrogen bromide. Alright, here we see we have a hydrogen, a nonmetal, and we have it in an aqueous solution. Once again, we have the binary acid. So we're going to name this as the acid. When you name a binary acid, you put hydro in front, hydro, and then the blank will be the nonmetal's primary name. So it'll be sulfur. This is an interesting one, because sulfur for the hydro binary acid will be sulfuric. You're just going to use sulfur, the entire name. So hydrosulfuric acid. Now, I bet many of you have actually heard of sulfuric acid before. Hydrosulfuric acid is not the same thing as sulfuric acid. Sulfuric acid is H2SO4, and we'll get to that later. But just know now that the word hydro in the front is very important. Now let me mention something here. Here we have H2S. Remember that sulfur, I said if you don't have this aqueous, you could also name it as the ionic compound. So sulfur's charge in an ionic compound is -2. Hydrogen group 1A on the periodic table, so it has a +1 charge. Whatever the charge of the nonmetal is, that will be how many hydrogens you have. Like, hydrogen has a +1 charge. If it's bonded to something with a -1 charge, like HCl, there will just be one of each, HCl. But because sulfur has a -2 charge, we need 2 hydrogens, we're just going to crisscross there, in order to balance that charge. So it's H2S. So, just be aware of that hydrogen has a +1 charge when it ionizes or chemically reacts in solution. And whatever the charge of the anion is, that's how many of the cation of the hydrogen ions you'll have. So I'm just going to summarize kind of what we've done so far in this chapter. We looked at the name of ions when we started, but basically we've been looking at naming compounds and how we would name compounds. According to the type of particles or the type of atoms in the molecular formula. So if you have a binary compound, which means you just have 2 different types of elements in your compound, you're going to look at what types of elements you have. If you have hydrogen nonmetal, you have a binary acid. If you have an aqueous solution, then you're going to name it hydroblankic acid, where this is the stem of the nonmetal that fills in the blank. If you don't have an aqueous solution, but you actually have the pure substance, HX, a solid, liquid, or gas, then you're just going to name it as the salt, hydrogen, and whatever the nonmetal would be. If you have a metal and a nonmetal, you have an ionic compound, a binary ionic compound. Remember, ionic compounds are always named cation, anion. If you have a metal with one type of charge, this is very easy. You just name the metal and the name of the nonmetal ending in "ide." An example of this, NaCl, sodium chloride. However, you have to be careful. If your metal could have more than one stable oxidation state, you need to indicate in the name what the charge of the metal is. There's 2 ways to do this. You can either use the stock naming system, where you name the metal but then put the charge in Roman numerals, inside parentheses, like 1, 2, 3. And then there's also the classic naming system, where you use the Latin stem of the metal root name, and you add the suffix "us" or "ic", depending on whether you have the lesser or the greater charge of the metal, like stannus, stannic, plumus, plumic, mercurus, mercuric, and so on. So if you do have a metal that contains more than one charge, you have to indicate the name, either using the stock or the classic system. And then the first one we looked at, it's actually the easiest, or the middle one we looked at, I'm sorry. If you have two nonmetals, you have a binary molecular compound. You have a molecule, basically. You're just going to use the prefixes to name the number of each atom in that compound. So for your binaries, these are the three types of compounds you can have. The first question you should always ask is, what types of elements are in my compound? And that will help you decide which of the three naming systems you're going to use.